My Lab 3 report. Lab 3 was in two parts. The purpose of the first part was we were observing a star around a black hole of unknown mass, and the goal was to find the unknown mass of the black hole. In part 2, we had a ship land on a planet closer to the black hole than the star we just observed, and the goal was to find the initial components of velocity to escape the gravitational force of the planet and the black hole. This was a computational only lab, so there really are no differences to preview between an observed model and the computational model, but the computational results are still really interesting in my opinion. So the momentum principle, circular motion, and gravitational force were used. For momentum principle, we know that this equation can be derived, and from circular motion, we know that F net equals these two components. So we can derive F net parallel using both these two equations. And since we know the overall net force and we can calculate the F net parallel, then we can derive F net perpendicular. Once all the F nets were found, then we could use the gravitational force equation to derive an equation to find the black hole's mass. In part 2, we were looking at the updated speed and position, so we were using the momentum principle for the updated velocity, the updated position formula, and the gravitational force formula to find the net force on both the planet and the ship. Once we figured out the F net, then we could use, obviously, like I said, these two equations to figure out the updated velocity and position of the ship and the planet. In part 1, like I said, the goal was to find the unknown mass of a black hole. The initial conditions given to us were the x and y components of the initial and final velocity of the star, and I thought that the system was a star, that the surroundings were the black hole, since the black hole is implementing the force on the star. In part 2, the goal was to find the initial components of speed for the ship. With the initial conditions given, where we were given the planet's initial speed, position, and velocity, and then we were able to change the ship's initial x and y velocity, and its position was given. So I thought that the system was the ship in this, and the surroundings were the planet and the black hole, since they were implementing forces on the ship. While the planet does have a force implemented on it from the black hole, and the ship, because we're more focusing on the ship and its updated position and velocity, I thought that the planet should be in the surroundings. Some initial errors that I just thought of: if you were to compare this to an observed model and it was in space, there could be other celestial bodies interacting with the model and making it either affecting the star's orbit or affecting the gravitational forces on the ship, and could just lead to errors within the lab. But if it's just computational based, then I don't really see any errors. So in part 1, my dummy email was changed to my GT email, my star's mass was changed, delta T was changed, the initial and final momentum, delta V, delta P were changed, and then obviously all the F net, parallel, perpendicular, dP, dP, parallel, perpendicular, dmag, pdt, all had to be updated to their derived equations. And then from that, we could derive the black hole's mass from the gravitational force equation. And then all the aeroscaling had to be changed so that the model looked nice and complete. In part 2, the black hole's new mass was input. The Tmax was set to 2 hours since the orbit was around 2.1 hours. The initial velocity of the ship was changed multiple times. Like I said, it was trial and error. And then obviously the R vector, R hat, R mag, and gravitational force to find the F net of the black hole and planet on the ship, as well as the force of the ship and the black hole and the planet, were found and updated. And then the F net of the ship and planet were updated to find their updated velocity and position. So in the first part, this video shows the star's orbit, and we can see all the arrows of the F net parallel, F net in general, and then F net perpendicular. And we can see them change in magnitude, as well as the F net parallel change in direction and magnitude as the orbit continues to go on. In part 2, this is the result, and we can see that the black hole is a dot in the middle, the planet's orbit's in blue, and the ship's trajectory is in purple. We were able to escape it, and we were able to do it at both the x and y component being at 1 times 10 to the 7th meter a second. So what does it mean? Was looking at how the net force is parallel and perpendicular components are different from the rate of change of momentum's parallel and perpendicular components. The net force for the parallel and perpendicular components are calculated using the delta of the magnitude of momentum, while the rate of change is using the magnitude of delta P. And while they seem close, they're very different. And I kind of put in this equation to show that they don't equal each other. And then this what if question was kind of a trial and error. Was that if you wanted your ship to kind of stay in orbit around the black hole but not hit the planet, what speeds would you have to go? And these were the speeds that I kind of trial and error got. Obviously, the orbit's longer, so it wasn't able to complete, and it may crash into the black hole, but I thought it was okay. And that's it.